that's all it'll take for them to, you know, call my juniors down. So looking at this multiplication up here, we have a trinomial. I told you all it would take would be for me to start talking. Juniors, I know we're going to lose about half the class. Have fun. Bye. Bring your stuff. We're going to talk about factoring. You've seen it before, but we'll talk about it again tomorrow.
Please get them seated as quickly as possible. Again, bring your items with you to the auditorium.
Thank you.
Thank you.
Basically, like, our entire class.
Half.
Huh?
Half.
I would say
They
over.
do not
But I'll-
care.
like 3/4.
It was technically one person more than half, which does not count majority enough that we need to go and suffer through the junior meeting.
Yeah.
Is that what y'all did?
Yeah. And then we had to fill out a sheet about, like, notes and stuff.
Huh?
We had to create our own groups and we had to sing in them. And then, like, we had to fill out a form with, like, notes and, like note names and stuff.
If you are a box person and you want to try and box multiply this, you can. It's just gonna be something that looks like this, and it's a hot mess. Totally fine. It works. It's just a lot of stuff. So you do not, I tend to do this with distribution because I feel like I can keep track easier. And I'm gonna close the windows. I feel like it's finally actually warmer outside than in, and it's not 100% humidity anymore. It felt like it was about to rain in this building when we first came in. So I'm gonna do this with distribution.
Are we allowed to use calculators?
A majority of the time, yes.
Okay.
But it is a relatively recent change in this class, so we're still kind of getting our feet underneath it. This class used to be no calculators at all until like February.
Yay.
So I was gonna say it was kind of a mix of it. They've just started changing the rules on us, which is super fun. So I'm gonna do this with distribution, and that just means I'm gonna take my 2x squared times all three of these pieces first, and then I'm gonna do my 3x, and then I'm gonna do my 5x, or my 5. So if I take my 2x squared times the x squared, that's gonna give me a 2x to the 4th. My 2x squared times that minus x gives us a minus 2x cubed. My 2x squared times the positive 4 gives us a plus 8x squared. Hopefully, you know where that's coming from. This is the chunky pen version, but that's okay. I'm gonna real quick scooch these down just a smidge because I know I'm gonna need that space. So then I'm going to do my 3x to those same pieces. I'm going to take my 3x times the x squared to get 3x cubed. I'm going to take my 3x times the minus x to get minus 3x squared. And my 3x times the 4 to get a positive 12x. And now that top is getting real arrowy, so I'm going to go ahead and switch and use down here. Minus 5 times x squared minus 5x squared. Woohoo! Minus 5 times minus x. Minus times minus, we get a plus 5x. And then, gotta get my arrow. Minus 5 times 4, minus 20. So we still get those same 9 pieces. If you did this in the box, they just wind up in that grid. It's the same chunks. We then just need to combine our like terms, because this is a mess. And tradition, habit, good grammar has us do biggest to smallest exponents. It's not that big of a deal, but it's kind of the best practice. So our biggest exponent is this x to the 4th, so our 2x to the 4th is going to be our starting place. Then we have our minus 2x cubed and a 3x cubed. So that's going to give us a 1x cubed. You don't have to put the 1. If it helps you to put the 1, put the 1. I genuinely do not care. Then we're going to do our squareds. I've got 8x squared minus 3x squared minus 5x squared. So how many x squareds do we have? None. If you want to put 0x squareds, because it makes your heart happy, more power to you. You don't need to put it. If it's not there, it's not there. Then we're going to do our x's. So we've got 12x and 5x, giving us a 17x. And then we have just sitting on the end over here is our minus 20. And this is how that multiplies. Okay, we did some of those with binomials yesterday where we distributed them out or multiplied them out. We can do that with any polynomial. I don't think I ever ask you to do another 3 by 3 again because they're really, really gross and long and very repetitive. There will not be a 3 by 3 on like a test or a quiz or anything because it's just repetitive and takes up time. But you might have 2 by 3s. Binomial, trinomial, those we'll see. But we should not see tons of trinomial. Or if we do, it should be simplifiable. Okay? So what we're going to do next is we're going to remember a little bit about undoing some of this multiplying. So we're going to start with some dividing. Hang on. My screen's freaking out. And there we go. All right, I've got 2 of them up here. This is what we're going to do with dividing. We're going to do one of them that's very familiar looking and one of them that looks like a hot mess.
Ew.
It's okay. I don't know why that has a set of parentheses around it. This is supposed to have a small square right there. I was like, why does it have a set of parentheses? I think it's sometimes Google and Annotate, which is the program we use on the iPad, argue over what things go where. And so it just wiggles my stuff around and it pushed the exponent off the screen. So we're going to take these one at a time. You guys have simplified like these before. 100%, because you did these in Algebra 2. Bless you.
Thank you.
We're going to start with this one, because I guarantee you're looking at the one on the right getting scared going, it's not hard, I promise. So it's, I promise. Because let's look at the one on the left. I'm going to switch view. There we go. So that we don't have to stare at that one for a little bit. Do you remember how to do this? How can we simplify this? Mm-hmm.
But like, you like put the 2 in like a corner of it, and then write out the coefficients of these things.
So that would be doing like a synthetic division, which totally would work. You just got to be really careful. Only problem is here with synthetic division, we need a root or a 0, and this has a root of at 0, not 0 the concept, 0 the number. So we would need a root or a solution for that.
Would we do GCF?
Think of it like a GCF. Really what we're going to do is we're kind of trying to uncommon this denominator. Cut it up into pieces. So what we're going to do is every place we have addition or subtraction up here, I'm going to cut these apart into separate pieces. So we can think of this as 8x to the 5th over 2x minus 2x cubed over 2x plus 6x squared over 2x. If we're dividing by a monomial, simplify it as fractions. It's going to be way, way easier than trying to do like a synthetic or long division. Those long division will work for sure on this. Synthetic division would be slightly obnoxious because of the fact that we don't have a root down here. If it was just a 2, I could see the argument for it, but if it's the 2x, then it becomes stickier. I'm sure there's a way to do it. It's just not in my head popping up. Because then when we get here, we can look at each of these fractions individually. If I just look at this 8x to the 5th over 2x, how can I simplify that? Just that. Yeah. 8 over 2 is going to give me 4. X to the 5th over x is going to simplify down to be x to the 4th. So this simplifies down to be 4x to the 4th. How about 2x cubed over 2x? The 2's cancel, and we're left with just an x squared. How about 6x squared over 2x?
3x.
That's our answer. Now let's try this one. Ooh, not that. All right, we can approach this very much the same way. We are very, very rarely going to see more than one letter in our problem like this. Our multivariate is what that's called. We're not going to have tons of that, but I just want us to see it every now and then because it can exist. We just don't typically do it. But we're going to approach this exactly the same way. Where we have adding and subtracting, we're going to break them apart. That one on the right, we're going to simplify as we put it into the fraction just because I don't want to have to deal with the parentheses. So if we have our 3m cubed n to the 4th over m cubed n squared, and then we have our minus 2m to the 5th n squared over m cubed n squared. And then we get our plus. What is m squared n squared as a group squared? M to the 4th n to the 4th. Because it's m squared n squared times m squared n squared. So we wind up with m to the 4th n to the 4th. And that's over our m cubed n squared. So splitting them up into separate fractions makes it kind of easier to look at these in small chunks. Because then we don't have to look at all these at the same time. We're just going to look over at that first one. If I have 3m cubed n to the 4th being divided by m cubed n squared, what are we going to have just from this piece? Our 3, the m cubes cancel out entirely, and we're left with just an n squared. In our middle term, what are we going to have here? Here we're going to have 2, and this time our n squared's canceled out, and we're left with an m squared. And then that last piece, what are we going to wind up with? mn squared. Told you it wasn't as hard as it looked. It's not exactly. We can do that. We can do that. So just because it has more than one letter doesn't mean run away screaming. We can do it. It also doesn't mean cry, because that's the other thoughts I get with that one. Okay, questions on these two? Dividing is not going to be a humongous part of this, but it's just one of those things we like to kind of touch on as it comes up every now and then. Because we've talked about multiplying them and dividing them and doing that kind of stuff. So what we're going to work on next is unmultiplying them, also known as everybody's most favorite thing, factoring.
I thought you did the trick.
I know. I'm horrifyingly cruel. There is some aspect of the enjoyment of the torture if you choose to be a math teacher, just saying. If I only wanted to be nice, it would be theater or art.
That sounds about right, yeah.
There's a slight amount of us that enjoys it.
I mean, if you include performing arts, Miss Dawson can get...
She can't, I mean...
Dawson and Stoll can get very scary.
I do not doubt that even a little.
I've always been scared of Wilson. I have not been scared of her all my life.
She's intense. It's okay.
We love her for it.
Yeah.
My older sister was in show choir, was in the choir, and she graduated in 21, so it's like 7 years.
I get it. I get it. None of them were my teachers. I'm way too old for that.
I keep thinking Steinberg was your teacher.
I was literally the year before.
Really?
He came my the year after I graduated. All right, so we're gonna start thinking about factoring, and just as a reminder, whenever we are factoring, it is super important. You gotta check for a greatest common factor first, and sometimes that'll just straight up be all you need to do. Because our goal when factoring is to get it to where we don't have exponents on any of our variables, ideally. If we are fully factored, there's no exponents on our variables. So we've got a couple in here that are doing that more than one variable thing, but it's still, we treat them exactly the same. So look at this first one up here. We've got x squared minus 7x. How could we factor this one? What do they all have in common?
Singular x.
A singular x. So I can take an x out of this. If I do, what's left over? If I factor an x out of x squared, x. And if we divide an x out of 7, we get a minus 7. Because it kind of mixes together the dividing that we just did. That's what we're doing to get this leftover bit, if you don't remember. We're figuring out what they share, and we're dividing that out of each of them. So let's look at this next one. Yes, it has more than one letter. It's okay, I promise. What do both pieces share in this 4x squared y minus 28xy? They both have a 4. Both are divisible by 4. They both have x's, and they both have y's. So we're going to divide 4xy out of both of those terms. So 4xy is our GCF. It's a gross GCF, but it's a GCF. If we divide 4xy out of 4x squared y, what are we left with? Just an x. If we divide 4xy out of 28xy, what are we left with? A minus 7. Okay. And then let's look at the bottom one. It's a little kooky dukes, but it's okay. 9a squared b to the 4th plus 27 ab to the 5th plus 81 a cubed b cubed. What do they all have? 9a b to the 3rd. We can take up to 3 b's out of every single one of them, but we can only take 1a out of each of them. So when we take our 9a b cubed out of 9a squared b to the 4th, what are we left with? Perfection. So we've got our ab left from our 9a squared b to the 4th. Say yes to all. I'm just going to slow it down for just a smidge, but yes. And then our 27 divided by 9 gives us our 3. Our a's cancel out. And we're left with just a b squared. And our last one, we have our 81 divided by 9 gives us a 9. A squared, and our b's cancel out. So always check for GCFs first. At this, I was like, we don't really have a way to keep going with this. It's technically further factorable, but we're not going to have to factor multivariates further than that, really. Check for a GCF, and that's pretty much where that's going to end. For the most part, when we're doing for realsies factoring, it's just going to have one letter. Most of the time, it's going to be X's. The book likes to toss weird ones at you. Q's, R's, Z's, S's. I try not to use S's too much because they look like 5s when I write S's frequently. Same reason for some of the other letters. They're just weird. So we are going to be doing a lot of factoring in this class. You need to know how to factor. I don't necessarily care how you factor. You just need to be able to factor. We are going to have a lot of times when we're working with those rational functions where we had like factoring over factoring, and then in another fraction we had factoring over factoring, lots of factoring. So we need to be able to factor, whether you X in box, whether you factor by grouping, whether you, I know some of the honors algebra teachers really drilled you doing it in your head. As long as you can explain to me how you got it, because sometimes I look at it and go, you did magic. Give me something to show me how we did it. I tend to use grouping up here on the board simply because, again, it doesn't take up as much space as an X in a box. It's the same pieces from X box. I'm just doing it in a line instead of making a square. So it's all the same pieces. We still need the little X frame thing when we're factoring by grouping. So if we remember that, let me see. When I say the X frame thing, I mean that's when we take our A times C at the top, B goes at the bottom, and we're finding our pair of numbers that multiplies to be the top and adds to be the bottom. That thingy? Vaguely familiar? So think about this first one here, our x squared minus 7x plus 12. Our A is 1, our C is 12. So we want to look for a pair of numbers that multiplies to make 12 and adds to make negative 7, because that's our B. Say it again. Negative 3 and negative 4. Negative 3 times negative 4 gives me a positive 12. Negative 3 plus negative 4 gives me a negative 7. Perfection. What this does is this tells me how these two pieces were before they got combined together. So it's uncombining our like terms. So when we did our multiplication with our binomials, we wound up with 4 pieces that we combined. This undoes that middle addition. So this becomes x squared minus 3x minus 4x plus 12. Same thing, 100% the same thing. When I say I'm going to factor by grouping, what I mean is I'm going to come through here and I'm going to say, well, I'm going to put you two together. And I'm going to put you two together. I will always take the minus sign into a set of parentheses. But I'm breaking them up into pairs. I am doing groups. I'm making groups. I'm making 2 groups. And then pretty much what you do is you just GCF those 2 groups. We're going to factor out those 2 pieces. I'm going to do this in 2 lines on this one, but typically I can do this all in 1 line. So if we look at x squared and minus 3x, they have in common an x, and I'm left with x minus 3. And when we look at our right pair, I have minus 4x and a 12. I'm going to take out a minus 4. If this piece is negative, we're going to take that minus with it. So we're going to take a negative 4 out as our greatest common factor. And that's going to leave us with an x. 12 divided by negative 4 gives us a minus 3. So we can do this with our factoring by grouping. We have one factor here as our x minus 3. Think of it as pulling that out as a factor, x minus 3. And our leftover bit of x, this pink x, and this minus 4. This is the long way to do this. I'm going to show you the shortcut on this one. The shortcut works when a is 1. So I'm going to show you a shortcut, and we'll use this a lot of times when we don't have an a of 1. But that's how this works. So this is doing it full tilt boogie, no shortcut. It works. When we have an a of 1, what I want us to see is that we got an x minus 3. Oh, look, we had minus 3 over here. We have x minus 4. Oh, wait, we had a negative 4 right there. Shortcut. So all we need when our a is 1 is just the x frame. We don't have to do the full factoring by grouping. If you want to, more power to you. It's totally valid. It works. But we can 100% take shortcuts. That's okay. So let's see this with the shortcut. We still need the x, because we need to take our a times c, 1 times 121. And our b is negative 22. What pair of numbers multiplies to make 121 and adds to make negative 22?
Negative 11. Wait, no,
Negative 11 and negative 11. So think about how we have our x minus 3 over here and our x minus 4 from up there. So we're going to have x, it's typically x plus whatever these values are. So it's going to be x plus negative 11, which is the same thing as x minus 11, and x minus 11. Yes. The other way you can write this, x minus 11 squared. Because we have the same exact thing. This is a perfect square trinomial. Bottom one, we'll do that one shortcut way, where all we need is our x frame. This one's A's. Other than that, we treat it exactly the same kind of vibe. Our first term times last term on the top, 15.
3.
So we need a pair of numbers that multiplies to make 15 and adds to make the worst 8 I've ever drawn in my life. Holy chaos, Batman.
3.
That's okay. You know what? It works. It's semi-legible. We understand the vibe.
Yeah.
Again, spelling is a suggestion and grammar is a construct. We get the point. So we can write this in its factored form, where we have our A with our positive 3 and our A with our positive 5. Factored. Okay? If your leading coefficient is 1, and there's not a letter that goes through as a GCF, there's not going to be one. So just as a reminder for that, if we have a constant and a something squared, there's no GCF. The only way we can have a greatest common factor if we have a term like this is if we just had, like, if we didn't have the 15. We had the 8 squared plus 8a, and I could take an a out. Okay, so I know you guys have done this before. We have been a minute, but we've done it. So I'm going to go ahead and say, let's be done there, and we will work with more factoring tomorrow. Yay! Where we're going to do some factoring with not just an a of 1. But then we're not flooring it too hard past all of our junior friends who are gone. Okay, I'm putting homework 3 up. I know there's a lot of stuff in this class. We fly. Yes, the first quiz is tomorrow, August 7th. To be fair, has been.
It has been on our thing.
It's on here, it's right there, quiz 1. It's over sections 1-1 and 1-2. So that would be the homework I just gave back. And homework 1-2, which was the one that is, and that one is over our, all of the radicals and the rationalization. So you got some time to look at those. I'll get the answer key for homework 1-2 posted up as well, just so you can look over that, so that since we have that quiz, I'll give you access to that information. So I'm going to go put that up right now. So 1-2, I will make sure to grade just basically on completion, since I'm going to put the answer key up for it right now. The 1-1 key is already up. I'm going to put the 1-2 key up as well. And where those show up, in case you're not 100% sure, if you go onto the Canvas page, I'm going to back out of this for a second. If you go onto the Canvas page and, boop, come on, give me a moment. So, from the home screen, go into our first unit. Scrolly, scrolly, scrolly. Here's where you can access old copies of notes if you need. Quiz 1's also right there. Boop, boop. So here's the homework pages. Here's our answer key. Here's the homework page. Here's our answer key. Okay? And it has, here's the 1-1, all the work in it. So you can see 100% where it is. I even put descriptions on these ones because the absolute value ones were a bit of a wild card on that first homework, just saying. So they're all there up in the Canvas page, and you can see those when you need to. Putting that back up. Yes, dear.